Okay, in this video, I'm going to talk about how to do the materials lab assignment. So here I have a file loaded up. There's the assignment files, A1. This is what your final image should look like. So you're going to be submitting renders from RenderMan with the picture of your reference and the shader you create. Obviously, these colors aren't quite matching up because the person who made this, we were trying not to give you, the obvious solution. So we want you to look at the references and try to match the references, not match what we make, right? I'm going to show you guys how to make a couple of these materials, probably not all of them, so you guys can have, the fun of figuring it out for yourself. But this is what we're going to be looking for. So please download this file. We've already set it up in a way that the teapots are arranged in a manner that's, looks just like this. The only thing you'd have to do is then Photoshop on these images. It already has the diagnostic spheres, and it also already has the checker charts. So, or chip charts, whatever you want to call it. Also, in here we have our source images. These should be in your VDEV rig, but if they're not in your VDEV, if you don't have the VDEV rig accessible, you'll want to also download these, and I'll show you guys where to put those. So let's see. Also, for some reason you can't open up this my file, I also have the camera and the different objects exported out. Cool. All right, so let's go ahead and take a look at this file. So I'm just going to open it cleanly. So I don't have a project set. Mine's just in a random project, doesn't matter. I'm going to go to a1.ma, right? So it looks like this. And if I render it, first, well, let's go ahead and talk a little bit about the contents of this file. Okay, first, we have different teapots. So you can see we have all these different teapots here. It looks like they're all visible, but they're actually not. And that's because I'm using display layers. So if you go to the channel box, come down here, there's display layers, which lets you toggle which teapots are visible and which ones aren't, because I put them in groups, right? I selected the group and I create a new layer like this, and then that's how I did it. I want to get rid of that. Okay, so we'll start with group one, right? You'll see with group one, we have one that's shiny plastic. That's what the name of it is. This one's matte plastic. This one is rubber, and this one's leather. Okay, and if we go back to that assignment, that is essentially the materials you have to create, right? You have to make a shiny plastic, a matte plastic, a rubber, a leather, aluminum, gold, copper, brushed aluminum, water, glass, frosted glass light bulb, and milk, wax, olive oil, and then we have this other one that's, I called it whiskey. It's just like a glass of whiskey. Okay, so let me go ahead, and we'll also, if you go to assignments, you should be able to as well. Oop, I'm in the wrong folder, but if I go back to assignments and read the document, we can see again all the different materials we're going to have to make. I have a lot of specifications on how I want you to submit this, so make sure you guys follow the rules with this. If you don't, I'm going to be annoyed with you. I also have this companion document, which is part of this. So essentially, these are tips and tricks that I give. Even after watching this video, if you're still confused about stuff, I talk about a lot about like what's going on and why we're doing things that we're doing. Cool. All right, so back into Maya. So each of these are named after the material you're going to have to recreate it. And when you recreate it, you're also going to want to find the reference image, right? So we have in here as well reference images. So for part one, shiny plastic is going to be this image, right? Matte plastic is going to be this image. So they're named based on the material that we want you to make it for. Okay. All right, so we have those teapots. They all are keyframed, so if you accidentally move them, right, if you move the timeline, it should do that. We also want to be looking through our camera, our render camera. So we have a second camera in here, so I just went panels, perspective, render cam. Here's our diagnostic spheres. And assuming you have RenderMan already loaded, these should all be good. If you don't have RenderMan already loaded and you open this file, it's not going to read the nodes correctly. And if you load RenderMan, the nodes are still going to may still be problematic. So if you don't have RenderMan loaded at first, you might want to just close this file, don't save over it, and then just load RenderMan first and then try opening the file again. And so you can just make sure, if you have the RenderMan tab right here, you can just click on this to load the plugin. That just makes sure it's active, because sometimes it doesn't auto load. And if you don't have it, installed, that's a different video, but you'll want to make sure it's installed and active by loading and unloading it, or loading it and auto loading it in the file. Okay, so let's go forward with this. So each of these teapots, okay, actually, let me show you this. So I'm going to go ahead and click on IPR to start an iterative renderer. And you'll notice right away that this doesn't look right. Something appears off. And that's because I'm using images for my lighting and for these checker charts. So both that environment, so if I go, I'm going to do this in 2-panel layout, just so we can see. I'll do this one. This will be the render camera, and then this one will just be perspective. You can see we have this dome light in the scene, right? It's in this folder, dome light, and that dome light, this is a RenderMan object. It has a color map it's loading, and so this file might not be actually set to, it's not going to be set to where your image is. So what we're going to do is we're going to go ahead and create a new project. So I'm going to go in here and I'm going to, let's do project window, wait, new. So we're going to go ahead and call this one, I think if I click new, okay, yeah, there we go. So we're going to call this one SIC underscore A1, okay? And I want this to be in here. So we're going to go ahead and we'll do a new folder. We'll call this one SIC assignments. Okay. So we'll select that. So let's see current project, let's see location, and then say accept. And hopefully if it all worked out okay, we're going to go over here to SIC assignments. And then as you see, it created a folder and it created all these default folders that Maya and RenderMan are going to like, right? And so we downloaded those HDR panorama images. So I'm going to go ahead and open a new version of this window. So we're going to do right click. Actually, let me do this. Open a new window. There we go. So I'm going to go to the downloads folder where I downloaded them. In this case, actually, I didn't download them, but I already have them. But if you download those files from the internet, right? Not these ones, but these ones, source images, then that's what we're going to put into that location. So for me, I'm going to go ahead and just bring that, the source images folder up and find where my other, those images are. So mine's in my VDev rig. I'm just going to copy these over. And I'm just going to come over here and paste them in there. Okay, so that's going to be easy to find and easy for me to, as long as I set my project, it's going to be easy to reference these images. So creating a project, I won't go too much into it, but creating a project essentially creates a space on your computer where this file is going to reference, right? So it's always going to look there first. It's going to kind of want to navigate there first, which is really helpful for loading in images and loading in other files. That's the bare minimum of what we're going to talk about here. So what I'm going to do is I can click here and I'm going to go to, and since we set our project, I'm going to go down to source images and we have our panorama HDR. I'm going to click on open. You'll see that image loads in. And then for those checker charts, I'm going to go ahead and all these objects are parented underneath the camera, so it always moves with the camera. So I'm going to select this checker chart, and I'm going to do the same thing where I'm going to come over here. You can see it has a material with a texture input coming in. I'm going to click on that, and again, find source images, color checker chart, color checker image, and then do the same thing on this one because this one has a different material. So we'll click on that object, go to the attribute editor, go to the material node, and then we're just going to reload that color checker in. Cool. All right. So now if I try to render this, it should. Oh. So what we probably have to do is we probably have to wait for it to finish loading my texture. So what we want to do is we want to click on this button right here, which is the texture manager. And what that's going to do is it's going to, any textures you load in, it's going to process them. So I'm going to click on parse scene, just make sure I don't have any. So it looks like it's got my color checker chart and my panorama image. So now if I render it, it should work. There we go. All right, so yeah, it wasn't working there, but now it's working. So you can see we have the complex environment in there, right? You can look at that little chrome ball. It's not just a white environment, right? It has an image on it, and then those color checker charts are coming in just fine. Cool. So this is what it should look like when you load it up and you got all your maps set up. So that's the first step. Again, the next step, what we're going to do is we're going to actually move this into ACES. So again, this is something I'm going to go ahead and stop my IPR. And if you want to, you can always grab this window and go window, always on top. And that way you can click in Maya and it's not going to bother it. Also, yours probably looks something like this. So what I like to do is I like to go ahead and turn off the inspector. I rarely use that. I turn on the catalog because that each time I click render, it's going to create a new image. And then I also like this thing down here, which is called the pixel readout. So I added that down there because you can see when I hover it, change it tells me the pixel values, which is cool. But then it also lets me change my color space, which we'll talk about in a second. And I can also change if I'm looking at like specific. I think that just tells me if I'm looking at specific things. Oop, okay. So let me just go ahead and stop that. All right, so I'm actually going to close this because we're going to switch to ACES, and the image tool needs to restart when we switch to ACES. So we're going to go discard that. Make sure it stopped. I'm right clicking and saying stop. Okay, so I'm going to go to render settings here, and I'm going to come over to RenderMan, assuming RenderMan's loaded, features. Down here under Open Color IO, we want to change this configuration to ACES 1.2. So that's going to change my scene rendering to being using the ACES color space suite package, whatever you want to call it. This just changes how light is calculated and how color is stored. So that's all you really need to know right now. It's what the mentors for the summer issue course prefer. So we're going to be using ACES for anything that we're going to be rendering. The default is going to be off, which means it's called linear sRGB, but we're just going to worry about ACES for now. Okay. So you'll see when I render again, I close my IT window, but now when I open my IT window, it's kind of hard to tell, but they look a little darker. The colors look a little weirder, and so the colors need to be fixed. So, but everything else is working pretty good, right? ACES, you know, when you go from linear to ACES, it's going to have like a slightly darker look to it. So I'll go and stop that, but we need to fix this because that's definitely a problem. So I'm going to go back to those to the texture manager. And so the texture manager is great for actually fixing our texture maps. So when I'm doing a different color space, sometimes my textures don't color correct for those color spaces because that color space is changing how color is viewed, right? Like we were using a different color space before, and now we're using a new one. And so because colors are being calculated and viewed differently, I need to adjust my texture maps to accommodate that, right? Because I want my texture map to still look the same more or less. So in here in the texture manager, I just opened that texture manager. We're going to come up here and we see our .png file, our color checker image. And I'm going to go ahead and down here to color space, we're going to set this to sRGB texture. What that's doing is it's telling the texture manager that this is a text, let's RenderMan know this was a texture map. It's in sRGB color space, which, you know, you guys don't have to know right now, but it's in sRGB color space. And when then RenderMan is going to convert it to ACES for you. For the panorama, I would do this as sRGB linear. And we don't have to worry about what that means right now, but any color maps, so anything with the word color in it, you want to do sRGB texture. Any environment lights, so .hdr or .exr files, we want them to be sRGB linear. And then anything like a normal map or roughness map or displacement map, we want that to be data. And we can talk about that more in a different context. So I'll go ahead and click on parse scene, and you'll see it's going to reconvert that panorama, and it didn't take very long. Okay, and now when I restart my render, it's still wrong. Let me double check this. Oh, right, I think I know what the problem is. Okay, no, I don't know what the problem is. Let me double check this 1 second. Okay, I figured out what I had done wrong. So when you select that color checker chart and you switch to sRGB texture, there's a little button here that says apply. So I forgot to apply it. So you just click on apply and then it'll convert it for you. So it will look a little bit something like this. It still does feel a bit dark, and that's because we're actually looking still through the wrong color space. So we'll come over here. And right now we're not actually looking through, what we want is we want ACES CG. So we change to, in here, we change to configuration, RenderMan, features configuration to ACES 1.2. Previously it was off. So now we're using ACES. We're using the wrong ACES color space, right? You can see this down here. That's why I like the pixel readout, but you can also find it up here under image color space ACES. And by default, it wants to go to 2065-1. So you guys don't have to know this, but this isn't meant for display. This is for archival purposes, for like storing images. So we're going to come down here to ACCG. ACCG is essentially like you want to look at it and you want it to be friendly for creating videos and images. So we'll click on that, and then the colors don't look so bad anymore. So those look pretty. They're like a little bit more saturated. Like it feels a little less dull, but it looks correct. Okay. So we've got our setup. Everything's looking good. We're now working in ACES. Now all we need to do is start doing our shaders. All right, so let's go ahead and start with the first material. So for all of these, we're going to be wanting to look at references. So we'll come over here. Let me go and pull this a little to the side, and we're just going to look at this one right now. But I'm going to go to assignment files, source images. Oh, nope, sorry. Assignment files, reference, part one. And we're going to start this one right here. You can actually select the object by clicking on this right here. So there's like a little select object tool. When I click on this, you can see it actually selects the object in the scene when I click on the image, right? If I click on that one, right? So it's pretty handy if you want to keep this window open. You don't want to like minimize this and go into the scene and select it. You can just click on the image and it'll select the object. But the image or this teapot right here is going to be shiny plastic. So we have this shiny plastic. So we're going to try to make it look like this one right here. So I'm gonna come back to it, but so let's go over here, and by default, they all have a single Pixar surface on it. You don't want to mess this one up. I'm going to assign a new material to each one of these. So we didn't make this materials for you. You guys have to create them yourselves because you have to get in the habit of doing that, right? But this is using like a default one, which is controlling that look, right? So before we go ahead and assign a new material, I'll just show you the settings really quickly. I have more in-depth videos on how to use Pixar Surface. So please look at that if you want to get a little bit more in-depth on how this works. But here we have the two main shading components that we need for group group one and group two, right? Which is going to be diffuse and specular. So diffuse is going to be the broad body reflectance, essentially the color of the surface and what reacts to light and does light and shadow. And then we have specular, which is the shininess. This is the reflections of the environment on the surface. Okay, so that's diffuse and then specular. So if I go ahead and turn specular off, this is what diffuse looks like, right? That's like that surface color, broad reflectance. And then if I turn the diffuse down, you can see this is pure specular reflection. There's none of that diffuse action going on up underneath the specular. Cool. So I'll set the game back to 1. Okay, so diffuse is pretty straightforward. Diffuse is just going to be, you're more or less just setting the color. I don't want you guys to have to worry about setting anything else, right? I use HSV for hue, which is the identity of the color, saturation, which is how intense the color is, and value, which is how bright or dark that color is. So I use that. Sometimes you might want to use RGB, but for the most part, you just do that. And you can use this color picker wheel if you prefer. Cool. I won't mess with this roughness attribute. There's advanced, but we're not going to mess with those two. Down here for specular, we are going to make a few changes sometimes. So by default, on all of these are called, let's go back to my folder here. So we have a difference between, let me go and pull up an example really quick. Okay, here we go. So we basically have two different material categories. There's more, right? So there's also, let me get rid of that really quickly, semiconductors. So we have what's called a dielectric, semiconductor, and conductor. Or insulators, semiconductors, and conductors. So this essentially has to do with how electricity travels through the material, which for making materials look like something, you might be like, why does that matter, right? I should just be able to change the surface quality and the color, and that should give me what I want. So, and this is using the physically based philosophy for making shaders, which is what a lot of materials in Unreal, all these offline renderers are all using. Is they're starting to move, they're moving away from using tricky, kind of hacky sort of rendering techniques, and they're actually basing on physical attributes that are measured in the real world. Using optics and chemistry. Essentially, though, we are going to break our materials down into two different categories. We have metals and non-metals. Sometimes you'll hear us say dielectrics. It's really useful to know that term, dielectric. And so it's metals and non-metals. So the reason why we categorize this is because metals all have a similar behavior to each other, And everything else pretty much is not like a metal, right? Like metals are very unique in the way that light interacts with the surface compared to all of these objects. So that's why we'll usually say metals and then non-metals, or metals and dielectrics. So what we're making right now is we're going to be making dielectrics. In this case, I am making that shiny red plastic. So this is a dielectric, this is a dielectric, this is a dielectric, this is a dielectric, because they're not metal. And then these four are metals. Okay. So we're going to, again, we're going to the shiny red plastic. Let's go and bring that back up. All right. And so what I'm going to do is down here for our specular, we have two ways of doing specular. We have a physical mode, which is essentially like using scientific values, right? Like real world measured values in order to create the intensity of our specular reflections and the color. Or we can use artistic, which is we are actually controlling by like adding color, or like changing the color of the reflections and value in order to do the reflections. So the main idea is you really don't want to do artistic mode. One is because it gets a little bit more complicated, right? Because now you have to worry about, changing this value to be something, a little bit more physically plausible, which is like around like 4%, right? But so that gets a little hard, right? Because you also have to consider like color management, right? Because color management's also playing a factor into it. But if you do physical mode, what's cool about physical mode is, one, by default, it's using one of the most common index of refraction specular values. So this refraction index is essentially, let me go ahead and bring up an example. So I'm going to touch on this very lightly. So if you're ever confused by this and you want to know more, well, you should know more, and I'm going to show you guys at some point physically based rendering stuff. And so it's really worthwhile knowing this stuff. It might seem kind of complicated and too technical, but it really isn't that bad. So essentially, when we do specular reflection, right? Because remember, from our basics on how diffuse and specular work, is that we have light hitting a surface, right? And some portion bounces off and some portion goes in. The portion that goes in bounces around, gets absorbed, scatters, and then comes back out changed. They're a changed man, right? The specular that never went in just kind of leaves separately, right? It's not affected by anything. So diffuse, right, is going to be that light that goes into the surface, bounce around, comes back out, right? So that's what we get for our surface color in lighting and shadow. And then specular is going to be the light that just bounced off. It never went under the surface. So just as a recap, that's what's happening. So what controls how much light is actually bouncing off versus going inside the surface is this value called the refractive index, right? So essentially, for controlling our reflections, right? So these are our reflections. We'll skip over the Fresnel effect for now. But the higher this index of refraction value is, means more light is bouncing off. So you can see on this is like a glass sphere. And what they're doing is, when the index of refraction is low, light isn't bouncing off, right? Light is going into it. And as it gets a little bit bigger, more light is bouncing off and less light is going through the object. And then as that gets higher and higher, more and more of the light just bounces off and doesn't go through the object. So you can see this starts to look more like metal, right? Because more and more of the light is bouncing off. And that's one of the things that makes a metal feel like a metal, right? Is those reflections, right? Is because mostly metals are reflecting the world around them, right? And you can see the reflected world. Whereas non-metals or dielectrics, right? They take light and then they start scattering the light under the skin, like across itself. And so it's not really, doesn't look like a reflection of the environment, right? It feels more of like light hits it and then gives it light and shadow. Okay. So that refractive index value is what's going to determine how much of the light's bouncing off. And you can actually look that value up, right? There's charts online. So if you ever want to look up this, IOR means index of refraction. So you can see most of these index refractions these are all dielectrics, right? So these are all non-metals, right? Water, fabric, liquids, plastic, eyes, skin, hair, teeth. So they're all around like 1.3 to 1.5, right? There's some higher ones like 2.3, but that's like very rare materials like a diamond. A diamond has a high index of refraction. So usually that value of 1.5 is pretty dang good, right? And then we don't have the index of refraction values here for metals, but metals, they're going to be, the index of refraction is much higher. And yeah, so then you can see the difference also. If we just use color, you can see that the reflectance value of dielectrics, because these are all nonmetals, are all very, very close to each other. But then the reflectance value for metals are very different, very bright, intense, and have unique colors. Okay, so we'll come back in here. So we're using physically based mode. We're going to do index refraction, just leave that alone. If you want, you can left click on that and they'll actually have some different types of materials in here. So you can see if I did diamond, diamond is 2.4, and let's go ahead and, so that's pretty dang high. So it's going to be a lot brighter, right? So you can see that difference, right? The higher the index of refraction goes, the more intense that reflected light is. So I'm just going to dial that back. And so as you see this go back, and then when it goes down to 1, essentially it's going to have like no specular reflection. All the light's going into the surface. But that's not what we want. We're just going to reset it to default value. Okay. So that's our specular reflection. The other thing we're going to change is the roughness. So that's how glossy and shiny my reflections are. So I'm going to go and right click on this image and say command snapshot, no AOVs. So what that does is when I'm running IPR, you can see when I change values, the renderer keeps updating, which is awesome. But if I want to save a version, like to compare, right, I went ahead and right clicked the image and said command snapshot, no AV. So it creates a snapshot right here. And then I come back to my iterative render and I'm just going to increase the roughness. So you can see here, this is around 0.2. Let's do like 0.23, something like that. I'll let it go a little bit further. We'll do command snapshot, no AOVs. All right, so you can see this is really, really sharp. This is practically 0. This is 2.4 something, 2.3, whatever. I'll go all the way up to like 5, right? And you can see this is getting really, really broad, right? So if I go ahead and drag and reorder this, right? So here's super sharp, here's kind of sharp, and here's really rough, right? Just like, so here's a couple things to keep in mind. And we talk about this more with like the physically based stuff is, nothing should go to pure black and pure white, right? Nothing in the world is pure black or pure white. Nothing. So don't ever choose black or white for values. You want for colors. You want to be just shy of black and white if you need to get something really bright. So if I was to do a surface color, right? And let's turn off the specular for a second, just so we're just looking at diffuse. Like that might be the darkest I'll ever go, right? And you can see it's like getting down to like 9%, you know, value, maybe a little bit lower, like 5%. There's actual values. So you can see this is RGB 0255. So there's actually values here that I have, and hopefully I can bring them up here on this slide presentation. Might have to pause and find it again. Let me pause that. Okay, here we are. So you can see 40 is the lowest sRGB color. So sRGB colors go from 0 to 55. And so 40 is the darkest it's going to get, and 240 is the brightest it should get. Those are real world values, right? You can see snow, one of the brightest surfaces you can have is 243 naturally. If I come back over here, if I'm using color or RGB 0 to 255, I'll probably only bring that down to 40. Oh, whoops. Sounds good. Let's set that to 40. Oh, wow. Okay, sorry. Let's do 40 and 40 for all of them. So that's like the color of coal, right? Or a really dark sweatshirt or hoodie or something like that. Okay. All right. So, and I accidentally turned on wireframe shading there. Cool. Same thing with specular. So you don't want anything. Let's go and bring specular back up. We don't want anything. Oh, sorry. Before I do that, also, we don't want anything pure white, right? Because it blows out. Nothing in real life is this bright, right? This like shader ball down here is the brightest thing that should ever be in your image, right? In terms of surface color. But these are all brighter than them. So that's just not naturally occurring. So I'm going to set this to 0. Oh, actually, this is even like 0.8, so it's not even fully there, but I would do something, let's say, yeah, I guess 0.8. Let's try RGB. I guess 240 is the brightest, so actually this isn't bad. This is actually, it did a good job. So it reined itself in. I guess this would be full 1, would be this, which looks very bizarre. I should probably not be using color management on that one. So anyways, I'm making this way too complicated. Let's just go back to HSV. And I'm just going to go ahead and set this back to like the brightest white. So that's the brightest white you should be working with. Okay. So anyways, so same thing. Let's go ahead and bring this back down to a darker gray color just because I like doing that to see the specularity. And then as we increase the roughness, right, those reflections get broader and broader. And then at low, it's reflecting the environment perfectly. So like I said, just no black, no full white, no zero roughness, and no full one roughness. It's always going to be some degree in between. One other thing I'm going to do as well is I'm going to go ahead and turn this off, and we're just going to look at the specularity. We're going to go Command, Snapshots, no AOV. Another thing is, this is a little more confusing and technical, but just do what I do here, is in RenderMan, if you come down here to Advanced under Primary Specular, we're going to go ahead and change Specular Model to GGX. So that has like a nice kind of feathering effect on your specular. So you can see that right there. So when you get really sharp reflections, like really solid shapes, it helps kind of make them feel a little bit more plausible and realistic. So that's another thing that we tend to like in this class and like doing and showing for these assignments. Okay, cool. So quick recap, where you got our diffuse color, diffuse, we have the color, the surface color. We have our specularity, which we're using a physical mode. And then we're changing the index refraction if we need to be for a different type of material, but for most non-metals, we won't have to change this, and we're mostly just worried about the roughness value. And then we also turn on GGX just to make our specular reflections look a little bit more pretty. Go ahead and start actually working on this assignment. All right, so what I'm going to do is I'm going to go ahead and select this teapot, and now it's time to assign a new material. So I'm going to right click on it and assign new material. I'll get this little pop-up window. Ooh. Okay, come on. I'm going to pull it over there. There we go. There, I'm going to try and remember how to pan. There we go. Okay. We're going to focus on this teapot. All right, so I'm going to go over here to RenderMan, BXDF, and we're going to come down here to Pixar Surface. So Pixar Surface, for like 95% of your materials, is the material shader you're going to want to use. So we're going to go ahead and click on that. So you'll see it change a little bit from the other ones. And so now it has its own material, right? So if I click on this one has that default material. This one right here has this new Pixar Surface. So I'm going to name it. I like to name it obviously based on the material. So let's go shiny plastic underscore MTL maybe, or MAT. I sometimes do that, or MTL. Depends on what your team's naming convention is. Okay, cool. So right now it's switched to artistic mode, so I'm not getting any reflections. So we'll come to that in a second, but I'm going to go ahead and let's try to get that color. So we're going to come back up here. Let's look at those references. So we want to get that shiny, it's like an orange red kind of color. It's a very bright color, but we do have to take into consideration that that environment is white, right? There's a lot of light bleeding through into that, like bouncing into that image. So it maybe looks artificially like too brighter than it should be. So in this case, I'm going to go ahead and just use this right here to try to get that color through this little color picker window right here. And I know it's like slightly orange, so the hue can change really quickly. So if I set this to 4, or let's say 7, right now it's starting to get pretty orange. So you got to be careful with it. Remember, hue is the unique identity, like red, green, blue, orange, purple, etc. That's like your color spectrum. So I'm going to set this to maybe like 4. That one's not bad. And okay, so you'll notice it's also, it takes a while for the IPR iterative render to update the image and not make it look noisy, right? So as soon as I make a change, right, it gets all this noise. So that's because it's rendering everything. But I really only need to render this teapot for now. So what you can do is you can click on this button right here. It's a little crop render, I think is what it's called. And you can click and drag this little red rectangle. And then when you press R on your keyboard, you'll see it only renders what's inside that rectangle. And for now, I'm going to go ahead and close that. I don't need to see it. Also, if you don't want to see those blue boxes, you can go to View and turn off Recent Bucket Markers. So now you can see that resolves very quickly, right? Cool. All right, so let's go ahead and go here. So I'm not going to go too far. Like I want you guys to really match it. For me, this feels a little bit more yellow orange like in there, but I'm not going to, show you guys how to do everything. All right, so here we have artistic mode. And again, if we're doing a non-metal, we don't want to use artistic mode because changing the specular value here, the face color, and then the edge color, So face color is the forward-facing reflections, and then edge color are the side reflections. So we want both of them. And you almost always you put the edge color to white or full. Don't worry about that right now. But edge color should always be pulled up to the max almost every time. But we want to use physical mode because that's going to give us a physically accurate value, which is determining how much light bounced off the surface for our specular. So that's one material down. So that's shiny plastic, right? I have to like adjust the roughness, right? So it looks a little sharper. So maybe I need to go ahead and bring this down a little bit. And then I might come in here and again, turn on GGX. Cool. So let's say that's what I wanted. All right, so now what we're gonna do, oops, let's go ahead and switch this back to the move tool. So we're gonna come over to this other material here. I'm gonna go ahead and draw a crop over it, press R on my keyboard to re-render. We can delete that crop if we don't wanna see it. So now let's work on our matte plastic. So I'm gonna go ahead and assign a new material. And we're gonna do Pixar surface. And for this one, it's gonna have a pretty dark surface. This is matte plastic. And it has a pretty rough specularity. So I'm going to go ahead and bring the surface color down. And I can double check this with a 0255. Might be a little too low. So we're going to go ahead and bring this up just a touch. Something like that. And then again, we're going to set this to physical, GGX, bring the edge color all the way up to white. And we're going to have to increase the roughness, right? Because this thing's pretty dang rough. Okay, so now I come back over here. And yeah, that looks pretty good. I think I could make the diffuse color a little darker if I wanted to, but I think that's good for now. So that's two materials down, right? So you can see with the non-metals, just these simple dielectrics that are like most of your materials, it's really just changing the surface color and changing that specular reflection roughness. That's really just defining these materials, right? Making them look like what they are, making this look shiny, making this look rough. All right, so let's go ahead. I'm going to skip forward to some metals. So I'm going to do essentially like two in each group just so you guys can get a sense of how it's working. So I'm going to go ahead and disable and hide that group. Oh, I might have accidentally removed this from group one. So we're going to add selected objects, and there we go. Okay. So now we're going to bring back this guy right here. Don't worry about what IPR is doing right now. We could restart a new render. Okay. So in group two, this top one is going to be aluminum. So let's go ahead and assign a new material. So assign a new material, Pixar surface. I didn't name my material for the last one, which was a bad habit or bad thing for me to do. So we're going to come here and call this one aluminum, I think, underscore MTL. Okay. So let's go ahead and zoom in on this. So hopefully you'll remember from our shader basics or from physically based shading that the difference between a metal and a non-metal is that a metal has no light that goes into it. So so most materials, right, some portion of light bounces off, that's a specular, and some portion goes in, that's a diffuse. So metals do not have light that goes in and bounces around. The light that goes in just gets fully absorbed, right? So that means we usually turn off the diffuse because there's not going to be a diffuse reflection thing, right? Because diffuse, again, is that light going in, bouncing around and coming back out. That's what's diffuse, that light that comes back out from under the surface. But metals, it doesn't come back out of the surface, so there's no diffuse. So what we're going to do is we're going to go ahead and make sure that we turn the diffuse off. And here you can see this is using a photography technique, but they're removing just the specular reflections in real life. And you see when you remove the specular reflections, the object has no surface color, right? It's black because no light is going underneath the surface and bouncing out, right? So that's pretty cool, right? So you can see this here too, right? Like they're turning that on, that removing the specular reflections. You can see there's still some color showing up. So watch, see that? You see how those metals get darker? The pure metal gets darker, but like rust and paint, those aren't metal. So those actually still stay behind. Those are diffuse. Those have a diffuse component to them even when the specular is removed. But all the pure metals get darker and darker and darker because they don't have that diffuse. So for metals, it's the appearance of it is almost all just reflection, specular reflection. Okay. So we'll go back here. And we'll pull this back up. So on that note, we're going to pull off the diffuse. All right, so here for the metals, we could use physical mode, right? And you can look up and so when you see this, the problem with metals, well, actually they have some presets. So we'll go to metal, let's say copper, and we'll set this one to metal, copper, and then we'll just change that, bring that up, that edge color up. So you'll see that like that looks like copper, right? But the problem is this is not user friendly. This is not artist friendly, right? Because it's using very specific values, and it also has this new attribute called extinction coefficient, which again, these are just not really useful for artists. Artists, you're not going to know these values, and it's going to be really hard to work with. So in that regard, I recommend for metals to actually just use the artistic mode. So again, edge color should just be fully white, and then we'll use this to change the color of our metals. And so metals aren't going to be fully reflective, so you can go up to like 0.8 or 0.5, right? And then we can change that saturation, right, which is going to make it look like a certain type of metal, right? So if we wanted to go for that copper or bronze, right, you can see that looks like bronze or copper, right? And we're just changing this specular color. Okay, and then similarly, we're just going to change the roughness and again, go back to GGX to get the reflective quality we want. So let's go back and look at that aluminum really quickly. So we're going to look at our references. So this is the aluminum. So it's pretty shiny, right? There's like not a whole lot of roughness to the surface. So we're going to let it go pretty shiny. So we're going to come down here and we're going to bring that roughness down pretty low. Again, we're not going to go to 0 because that just does not make sense. All right, so also the problem here is aluminum does not have a color tint to it, or if it does, you would consider it like gray or desaturated. So we're actually going to just bring saturation down. That's probably one of the easiest ways to do it. We can add a little saturation, and I might make it like in the blue region. Depends on like the metal, right? But this one, and maybe bring this down to like 0.05, right? So it has a slight tint to it, but not a whole lot. So that's my aluminum. I think my value might be a little too high. So I'm going to bring that down a bit. So yeah, it was a little too high. So I might set that to like somewhere around 0.8. So if that's a little bit more physically correct. And there, that's our aluminum. So we did aluminum. Now what's the next metal we're going to work on? Let's do, I think it's copper is the next in line. So, oh, gold is next in line. So let's go ahead and take a look at our gold. So our gold is here. And again, it's pretty shiny. It's very similar to the aluminum. It's probably even shinier, right? And then it has this really pale yellow. You know, golds can look very different. You know, it can be like very orange, and then other times it can be like this really light yellow color. So we're gonna come back over here, and I'm gonna go ahead and crop render. Ooh, oh, whoops, my bad. I clicked on the wrong tool. I'm gonna go ahead and crop render this one right here. Press R on my keyboard to restart the render. And let's go ahead and switch the move tool, move over here, switch back to crop render, click on that, and click on that to hide that. Okay, and so we're going to assign a new material. So this one's going to be Pixar Surface. All right, and we're going to call this one gold underscore MTL. All right, so same thing, this is metal, so it doesn't have any diffuse. We're not going to use artistic, or we're not going to use physical mode, so we're going to use artistic mode because it's a lot easier. We're going to bring the edge color all the way up, and for the face color, we can go ahead and set it just like the other one, so 0.8. So we know that reflectance value, 0.8, is pretty good, right? Like that's a pretty good amount of light to reflect. Any higher, it starts to look a little unbelievable. And now we're going to go ahead and get some saturation up, not too much because it's kind of pale. And then we're going to go ahead and get that color we need, right? So it's something maybe a little bit like that, right? Let's go ahead and take a look at that. So that's pretty good. I might pump like it's hard to tell because the lighting of the environment can really change things. You know, I could pump that color or that value a little bit higher to get a little bit of these darks to lift up a little bit, but and also maybe a little bit more saturation. Okay. That's what I'm noticing, right? You got to trust your gut. You got to look at that reference and you got to really analyze it and understand what's going on. So I'll push that saturation just a little deeper, and I might also make that value just a little higher. So we'll just, oop, not that one. And we'll just set this to 0.83, maybe 0.86. This is getting a little too bright, but I think that looks pretty good. Stop it. Okay, cool. So now we have our aluminum, and our gold. Again, I forgot my gold. I needed to change it to GGX. And again, this one's going to be really glossy. Glossier than the aluminum. So I might even rough up you can see it's a little bit less reflective over here. I think I'm making both of them a little too shiny. So I'll go ahead and select that. We'll select the aluminum, increase that roughness a bit. Oh, yeah, increase that one's roughness a bit. So let's go ahead and reset our render because I can't see that because I was dialing it off. So I'll set that roughness down. So it's still pretty shiny, but not shiny as that gold ring. Cool. All right. So that's two of the metals done. Let's move on to the next group. Okay, so these are where we're going to get into our translucent and transmissive or refractive materials. So essentially materials that are like skin and then materials that are like water and liquids. I think this might be the liquids group. Yeah, so these are going to be the liquid and the glass group. So it's going to be refractive. And the reason why they're kind of grouped together is they let light mostly through, right? Like you can mostly see through water, you can mostly see through glass, whereas all the other dielectrics you can't really see through them. So liquids and like these types of liquids and then materials like glass, they have a structure in such a way that you can see through them, and they're still dielectrics. They're kind of the same category as wood and stone and plastic. So first group I have is water. So what I'm going to do is I'm going to go ahead again. I put this over here. So we're going to assign new material, PXDF, Pixar Surface. And we're going to call this one water underscore MTL for material. And you'll see also, we'll see, actually, we'll look at it in a second. I'll show you guys. I'm also going to do a crop render. So I'm just going to select this, start rendering it. Okay. So I'm going to come down here to gain and specular. So the problem is for most dielectrics, right, we have diffuse and specular, like most nonmetals. And this water isn't a nonmetal. But the problem is because the calculation of how to like make light travel through a 3D object is so different, right? Because RenderMan is doing different calculations to make this look like plastic versus making it look like glass, right? It's like a completely different algorithm and technique. We're not going to use these shading settings up here. So we're actually going to turn for all glass materials and all liquid materials. We're going to turn the diffuse off and the specular off. Okay. We're going to come down here, and for liquids like water and crystals, materials like crystals and glass, things that we can look through, we're going to use the glass attributes. So what we're going to do is we're just going to turn the refraction and reflection gain up. And that's going to essentially just give us the ability to render light traveling through the object. And so down here we have, again, you'll see refractive index, right? So that's going to be how much light bounces off the surface or goes through it. So this one has, right, remember we can look up the value, but it also has some stored here. So 1.33 is generally the index of refraction for water. And we probably, I think there should be a way to, no, that's okay. All right, down here we have a lot of different settings. Refraction color is going to be the way that we can change the color of the liquid or the glass, right? If you want it to feel like it's a beer or whiskey, right? We gave it this kind of like warm yellow color. I'll set that back to default. And if you ever need to, you can left click and say revert to default on a node. Roughness is going to actually change the roughness of the light coming through and bouncing off. So the higher the roughness, you know, the more the light that's coming through blurs, and the more the light that bounces off is also blurring. So if you're going for like a frosted glass or like a murky kind of liquid, then that makes sense, right? To increase the roughness of the light coming through. That's what refraction is. But sometimes, let's say I wanted like milk or like some kind of orange juice. Let's say orange juice, right? Orange juice, I want the light that's coming through to be rough, but I want the light that bounces off the surface to be shiny, right? Like look at a glass of orange juice. This top surface is very shiny. So, you know, how do I make this rough and have the specular not be rough? So there's this value right here called refraction roughness. And if you hover over it, it'll tell you if this value is negative, then this attribute here controls both the light coming through and bouncing off their roughness values. But if I go ahead and I'll bring this down here, if I go ahead and bring this refraction value above 0, You can see now I can change the roughness of the light coming through, but not change the roughness of the light bouncing off, right? So that's a way that I can make it look like, like let's say ice, right? Ice is going to be shiny on the outside, but rough on the inside, right? So that's just how we can do that. So in this case, though, for water, I'm probably not going to have um, like really barely any roughness, right? Depends on the quality of the water, right? If there's like a lot of particulate matter inside of it or not. Again, the surface is going to be pretty shiny, kind of close to aluminum, right? Because it's a pretty smooth surface and it doesn't have a lot of distortion to it. So that's glass. You also notice how much it's warping and distorting the world, right? So if I come over here and turn off that backdrop, right here, if I turn off that backdrop, we should be able to see the environment. Oop, oh, dang, pressed it twice. There we go. And then let's go ahead and select that environment. And I'm going to make sure it's visible in the renderer, because by default it's not. So we'll just go ahead and go to this right here. And it'll load in a second, hopefully. Let's go ahead and stop that render. Sometimes when the render is running, it doesn't help. So I'll turn that on. And I'll go ahead and IPR this, and then render. So we'll have that on just so we can see that background. If you wanted to, you could also turn on, oh, I have it in a different one, clean backdrop. It doesn't matter. Okay. So we'll see this on the next material. This one right here is going to be thin glass. So I'm going to go ahead and select this one right here. And this one is called empty glass, not thin glass, sorry, empty glass. So you'll see the main difference is that the models are significantly different. Let's go and stop that render. So you can see this one right here is hollow, and this one right here is solid, right? And that's actually going to affect the light traveling through it. Like imagine if you had a glass, like if you want to go observe yourself, go get it, like a clear glass, right? Look through it, and then pour water and look through it again, right? The more there's of a medium there is in there, the more it's going to distort and warp the light coming through, right? It's not going to like make it fuzzy, it's just going to move the light and bend it more. And so here's an example of that effect, right? When you have a thick medium that the light travels through, and you're using like a refractive or transmissive material where light can travel all the way through, you're going to get more of that distorted effect. And if there's less, right, because it's empty, it's just thin walls, less of that material travel through, the effect is way less noticeable. So let's go back. And so that model is very important. So that's why we have like water, or this could just be glass and empty glass, to be honest. So let's go up here and let's bring back image tool. So I'm going to go ahead and I'll get rid of that. We'll go ahead and assign this a new material. Assign a new material. Fix our surface. Fix our surface. There we go. Okay. And then I'm going to go ahead and name this one. Then, or we'll just call it empty glass MTL. Okay. And same concept as before, I want to turn off the diffuse, make sure the specular is not on, and I'm going to turn on, turn on the reflection and refraction. Okay, so let's go ahead and render this out. And we're going to go ahead and I'm going to bring back that backdrop just so we can see this a little bit better. So do that. And then I'm also going to do a crop render so we're not rendering those other guys. All right. So you can kind of see that with the image coming through, it's a little hard to tell, but let's see. So this one's getting really warped and distorted. You can see this feels thick, right? And this, I can see that inside of like the other side really clearly, right? It's not that thick. So that model is really changing how much light is bending, right? This is a thick, solid volume. This is an empty, hollow volume. So that light traveling through is pretty much undisturbed. And so again, those settings, roughness and refraction roughness, are going to change how the color and the look of this. Is just an empty glass, so if I might bring the roughness down a little bit on that one. One thing you might notice, or maybe not notice, is this happens a lot when you're rendering for like a scene or a shot. That I'm going to snapshot this. Your glass sometimes looks a little dim or dark, and that's usually because of the light, how much light is being calculated in the scene. So if you open up your render settings and come over here to samples, down here, if you're using the Pixar path tracer, we have these values down here, which is specular depth and diffuse depth. Mine actually might already be set nicely. And we also have this max indirect bounces. But this value right here, if I went ahead and set this lower, so let's say 2, right, you'll see that that light is essentially, this is saying how many surfaces the light ray will hit before it just stops and disappears, right? So the light hits the outer surface, then it hits the inner surface, and then disappears. And so that's what's causing this interior to feel dark and black, right? If I set this to 1, right, it's even darker. And if I set it 0, there's going to be no light going into the surface. So I was using 6. You could theoretically go up to 8. You probably don't need to go up to 8 on y'all's, but you know, I'm sitting on a desktop and it's a pretty powerful desktop, so I can afford to do that. So if we go back and look at that, right, you can see my glasses, even just going from 6 bounces to 8 bounces, my glass is just a little bit brighter, which is nice. Cool. All right. So there's another one down here that's called light bulb. So just be aware, light bulb is going to use, and this is, I'm not going to go over this one because I want you guys to have that challenge. It actually has 2 objects to it, right? So let's go ahead and stop that render. I come over here and isolate it, right? If I hide this, let's go ahead and let's just isolate the filament. So there's a filament object in here. And so this one we want to emit light, right? We want this to shoot light out. So there's actually 2 models that need 2 materials in it. So I'll let you guys figure out how to do that. But I just wanted to point that out, as some of these have multiple models in them. So let's move on to the last group. Okay, we're on the last group, and these are going to be our scattering surfaces. So, well, actually 2 of them are scattering and then 2 of them are going to be refractive. So, but these 2 are going to be unique because they're going to be using a completely different shading component on that Pixar surface than what we've used before. So what I'm going to do is I'm going to go ahead and assign a new material. This one we're going to create milk. So milk we could make it with the glass material and do liquids, but in this case I'm going to try to do it with what's called subsurface scattering. So I'm going to right click on this and I'm going to go ahead and assign a new material. And we're going to go ahead and go to Pixar surface. And we're going to set this to milk underscore MTL. Okay. And so we're not going to be using glass, obviously. We are going to use specularity, right? So we're going to turn the specular on. Let's go ahead and get that render going. IPR. Okay. You'll see there's a little drink cuppy down there. So I'm going to go ahead and just crop render this one so that my render goes faster. All right, and then what we're going to do is so with subsurface scattering, it is essentially doing what diffuse is doing, but is doing it in a more advanced and sophisticated way. So the difference between diffuse, so like most materials, dielectrics, right? Light actually enters the surface and scatters around, right? Rock, you know, leather, plastic, right? Things around you, light is actually entering the surface and scattering around. That's how we get this broad reflectance, you know, lighting and shadow. But for most dielectrics, it's very shallow, right? Like it barely enters the surface before it comes back out. But then translucent materials or scatter materials, they're going to have light penetrate deeper into the surface. So with glass, it goes all the way through, and with something like a subsurface scattering like skin or organic material, it goes in and it might come out on the other side, but it's usually not, it's usually kind of blurry, right? So this is like glass, and then this is like a translucent. So this is translucent, this is transparent, right? Translucent is partially light comes through, transparent, the light goes all the way through. So you can see opaque, translucent, transparent. And then I have some examples down here, right? So subsurface scattering is this phenomenon for dielectrics. These are all dielectrics, non-metals. So light goes through the object a lot like the glass, but you can see it, we can't see the image through the glass, right? So it doesn't travel, when it travels through, it either scatters a lot, so it bounces off of a bunch of stuff as it comes through, so the image isn't clear when it goes through, or it just absorbs a lot more of the material as it goes through. So I'm going to go back over here. So we do have specularity, but we're not going to use diffuse, because for the diffuse component, we're not actually doing light scattering. So if I put a light source over here and push it through, that light source isn't going to show up through the model, right? So we're going to actually turn the diffuse off. And we're going to come down here to this material setting down here called subsurface. So this is what's called subsurface scattering. It's scattering of light beneath the surface, right? That's what subsurface means. And so we'll bring the gain all the way up to 1. And this is going to be really expensive, so just keep that in mind. It's a very expensive shading like technique. So we have this material here, right? We're going ahead and, you know, creating this effect of light scattering. And if I bring that down to like the gray that we had before, let's go to something like that. Yeah, let's do something like this. You'll notice as it cleans up that there's light scattering through it, right? There's like a warm color that's traveling through it. So if we looked back at some of these gray teapots, hopefully we have one there is a gray teapot, right? Like you can see light travels through. It's a little gross and it's not exactly what we want, but that's the effect it's having, right? And so this once we turn this gain on, we're essentially replacing diffuse with this different shading component. This color is going to be the surface color, so that's the color of the model surface. This right here, mean free path color, is going to be the color tinting of the light traveling through the object and coming out in a different location. So that light that scatters from one side into another side is going to be tinted this color. This value right here tells the program, the RenderMan, like how deep light is allowed to scatter, right? If I bring this down to 1, right, light doesn't scatter very far. If I bring that up to 20, right, light scatters very, very far. And it has the effect of making things look hard or gummy, right? Higher the value is, the more gummy it looks. The lower it is, the more hard it looks, like solid it looks. Okay, I did this a little bit offline, but I'll go over the settings I used. Also, just remove the cap on this model just so I could see it better. You guys shouldn't have to do that. But you can see I duplicated the water teapot and just brought it in here. So I just wanted to make sure I got this set up correctly before I showed you guys, because that could be potentially disastrous. What I did was I went ahead and we're just going to assign a new material. So we'll go ahead and stop the render. And we'll, object mode, assign a new material. We're just going to go through that again. So Pixar surface. We'll call this milk v2 MTL. Okay. All right. And let's call this milk geo. Milk underscore geo. All right. We're going to go ahead and start that IPR again. IPR. Okay, we'll go here. Again, we're going to turn off the diffuse, right? Because subsurface scattering is going to be taking care of the diffuse for us. We are going to use speculator. So we're going to switch to physical mode. We're going to go ahead and turn on GGX. Make sure edge color is white, and then bring the roughness up a little bit, because this is going to be like a liquid, right? Surfaces of liquids are usually pretty dang glossy. Okay. So we come down here to subsurface. So we're going to click on that. And so we have a bunch of different subsurface models, right? So this is just the way that the renderer is calculating light and essentially figuring out how light travels through the object and using mathing equations, right? So we're going to go ahead and turn on the gain for the subsurface scattering. And so some of these are better for different reasons. On the RenderMan website, actually, I think if you hover, it tells you too. Let's go ahead and go here. So Jensen, Dipole, and Dion are better dipole profiles for subsurface diffusion. So that's after many bounces or scattering. Burley is normalized for both diffusion and single scattering. Path trace implements brute force. Only Burley and path trace are available in XPU. So you guys probably are like, what? I don't understand what that means. You guys don't have to worry about it right now. But for the most part they're just calculating it slightly differently, and there's not like a true good model yet for all different types of subsurface scattering. So in this case, I would recommend you guys try them out. I think don't do multiple mean free path, but Dion better dipole, Burley normalized, and these two path trace ones are good. So the Burley normalized and the Dion, actually I think the Jensen might be better. Let's do the Dion. So we'll do Dion. Is going to be what's essentially I'm just going to use this one. So this distance right here, mean free path distance, I think that's pretty dang good, right? Let's go ahead and change this color, right? So we want this, milk is kind of a cream color. So it's honestly, this color isn't too far off. I might go ahead and make it a little bit yellower. Let's just go a little bit more in the yellow spectrum. And then that surface, right, I might also tint it a little bit, right? So maybe not quite that much, but let's see what that looks like. Cool. So I think that's looking pretty good. What I'm going to do as well is, so what we might want to do is we might want to check our lighting. So what I'm going to do is I'm going to hide this light source. And I'm actually just going to go ahead and add in over here a new light. So we're going to stop that light. We're going to go ahead and create a Pixar rectangle light. I'm going to look through it. So I'm going to click on look through selected. Now that's me. It turns the light source into like a camera, which makes it easier to position. So we'll go back to perspective. So it's right over there. And I'm just going to scale it up. Like that. And we're going to IPR it. And we're going to, let's go back down to here. We're going to have to change the intensity of this guy a bit. All right, and so let's just go ahead and set this to pump this exposure up. It's a little too hot. So it's a good idea to try testing your materials, or like your scatter materials, with like a side lighting situation, right? Because that's going to show you how deep or how far the light travels through it. So if I came in here to my material, so we'll go to Milk Geo, we'll just do command snapshots, no AOVs. If I bring this mean free path distance value down, right? Let's go down to like 0.4. The color noise is always really gross. Let's just go to 0. You can see right here, right? Like you can see the light travels further into it. I need to like clean this up more, right? It's taking a long time. And actually this kind of surface up here is kind of bad. And I think that's probably causing some artifacts. But you can see right there, right? That light is bleeding through, and gives it a softer look, almost like it's jade or something like that. So I'm gonna go ahead and get rid of that rect light, and then I'm gonna bring back my environment panorama. And then we're gonna re-render that there. Let's like that. Hopefully, I'll just re-render it. Cool. Okay, so I'm not going to do the other ones. I'm going to leave that up to you guys. The final materials are going to be wax, which is, going to be doing something similar. That's that one right there. Olive oil, which is going to be a liquid. And then a whiskey glass, which is going to have actually multiple objects in it again, just like the light bulb. So there's going to be a metal straw, and then there's like whiskey material, and this is going to be like a whiskey glass. So hopefully this is helpful. Good luck. Don't forget that at the end you want to go ahead and export your images. So let's say we'll go to like, let's see, let's say this is the one image I liked, right? And let's say I did all 4 of them. So for when I finish these materials, what I'll do is I'll do file, export file, and we're going to do a JPEG, and we're going to upload it to our downloads. So let's just call this one group 1. Well, or we can say something like this, A1 underscore group 1. And that saves out an image for us. Cool. So if you have any other questions, please let us know. But other than that, you should be good to go.